Okay, so we're going to do 14.12. So again, we are given the firm production function Q equal to 20 K0 to the power a half and L to the power half. Okay, so the price of capital is R equal to 3 and the price of labor is 12. Okay, so part A asking you to write down the quantity of labor that firm will need to hire as a function of its short run output L equal to a function of Q and K. Okay, so basically in the short run K is fixed, so therefore it's equal to K0 and L can vary. Okay, and the question asking you to find out the function L as a function of the level of output Q. Okay, it's like QF. Alright, so the firm will be okay, so we're using the production function QF equal to 20 K0 a half and L a half. So if we square both sides of this equation just to get rid of the power sign, then we got QF square equal to 20 K0 a half L a half and everything square. Now 20 square is 400. Okay, K0 half square is going to be K0 and L half square is going to be L. Okay, so from here if we rearrange it, we'll be able to find that L is equal to QF square, everything divided by 400 K0. Okay, so here we're having an L function as a function of QF and K0. So part B asking you to write out a firm's short run cost function C as a function of Q, and so therefore obtain the marginal and the average cost function. Okay, so we know that the short run cost function C for the firm is just going to be the cost of labor and capital. So that is R times amount of K, which is K0 in this case, and W times L. So we are given that R equal to 3 K0. So remember K0 is just a fixed number, okay, because it doesn't change in the short run, and plus L times W, so L is just equal to QF square, everything divided by 400 K0. Okay, and sorry, we know that W is equal to 12, which is given to us. So if we simplify this, we get 3 K0 plus, so 12 divided by 400 is 100 on 3. Okay, so simplify that will give us 3 QF square, everything divided by 100 K0. Okay, so this is our cost function as a function of Q. And so therefore the marginal cost is going to be just the differential of the cost function with respect to QF. Okay, so if I differentiate this thing with respect to QF, now 3K0 will disappear because it's just a constant number, and 3 QF square on 100K is going to give me 3 on 100 K0, which is just a constant, times 2 QF. Okay, so that is just going to be 3 on 50 K0 times QF. Okay, and the average cost is just going to be the total cost function divided by QF. Okay, so that would just give me 3 K0 on QF plus 3 QF 100 K0. Okay, so part C asking you to show that the firm is minimizing the average cost by producing at the quantity QF equals to 10K0. Alright, so I got average cost function over here is 3K0 on QF plus 3QF divided by 100K0. Okay, so to find the minimum point of this, okay, then we just have to find the first order conditions where we differentiate the total, so the average cost function with respect to QF and make it equal to 0. So if I differentiate that, it will give me, so this is 3K0 just basically times QF to the power -1, okay? So therefore when I differentiate, see if I write like this to make it easier for you to differentiate, okay? And that is 3 on 100K0 times QF. So if I differentiate, I'll get 3K0, which is just a constant, times -1 QF -2 plus 3 on 100K0, okay? Times QF, and when you differentiate, that will just become 1, okay? And the whole thing becomes 0. So this would just be -3K0 everything divided by QF square and plus 3 on 100K0, and that is going to be equal to 0, okay? So I'm solving this equation for QF. So if I move this term to the right hand side, that will just give me 3 on 100K0 left on the left hand side equal to 3K0 on QF square. Okay, so 3 will cancel with 3, and so therefore QF square is just going to be equal to K0 times 100K0. Okay, so the number 3 will just cancel out, and that will give me 100K0 square, and so therefore QF is going to be equal to 10K0. Now I just ignore the -10K0 because we do not care about a negative quantity, okay? So if you take square root of both sides of this equation, you get QF equal to 10K0, which is the positive number that we only care about. Alright, so part D is asking you to confirm that the output QF equal to 10K0. Okay, sorry, so this part over here, now in order to confirm that what we found is a minimum point, just to make sure that we did the right thing, you just have to differentiate again in the second order conditions, and it is going to be a positive number, okay? So if anyone wants to confirm that, you can do that as well. Okay, so the second order conditions where I should differentiate the first derivative again with respect to QF. So if I do that, I will get -3 K0 times -2 QF to the power -3, and this is just a constant number, so that will just disappear, become 0. So this is my second derivative, okay? And so as you can see, is just 6K0 divided by QF to the power 3, and so given that QF is a positive number or a non-negative number, then this thing will just be bigger than 0, okay, for any QF bigger or equal to 0. I'll just say bigger than 0 because it on denominator, so it can't be equal to 0, okay? So if this thing is positive, then we confirm that the point QF equal to 10K0 we found earlier in the first order condition is a minimum point, okay? So that is the quantity that is minimizing the cost function for the firm, the average cost function, okay? So part D, asking you to confirm that for output QF equal to 10K0, the firm's marginal and average costs are equal with each other. Okay, so the marginal cost for the firm that we found earlier is 3 on 50K0 times QF. Okay, and so given that QF equal to 10K0, so that will just, so K0 cancel with K0, that become 30 on 50, which is 3 on 5. Okay, and the average cost we found earlier is 3K0 on QF. Plus 3QF on 100 K0. So if we substitute the values of QF equal to 10K0, okay, then we will get so K0 cancel K0, I got 3 on 10 over here. And this is 300 on 100, which is equal to 3. Sorry, 30 on 100. So that is just 3 on 10. Okay, and K0 which is cancel K0, so that will give me 6 on 10, and so that is just 3 on 5. Okay, so as you can see, the marginal cost is equal to the average cost at the quantity QF equal to 10K0. Okay, and that is equal to 3 on 5, which is 0.6. So confirm that the market supply function. Now, so the basically the important things about this is to just tell you that the marginal cost and the average cost curve is going to cut each other at the minimum point on the average cost function. Okay, so when you draw a diagram like I mentioned before, okay, then so if this is the cost and if this is the quantity, so if I got average cost function is somewhere like this, okay, and this is the minimum on the average cost, then the marginal cost is going to cut this average cost at the minimum point on the average cost. Okay, so that's the characteristic that the question is asking you to prove. So at the minimum point of the average cost, the marginal cost is going to be equal to the average cost, which basically is saying that marginal cost and average cost are cutting each other at the minimum point of the average cost. Okay, so when you draw a diagram, make sure that you always get this right. This is always going to be the case, where marginal cost is always going through the minimum point of the average cost. Okay, and so part A, confirm that the market supply function is 10,000 K0P on 3. Okay, so to find the market supply, the first thing we have to do is to find the firm supply. Okay, so we find the individual supply for each of the firm first, and then after that we add all the supply together to find the market supply. Okay, so the first thing we want to do is to find the firm supply in the short run. Okay, so the firm will be supplying at the point where the price equal to marginal cost. We know that, okay, and the condition for the firm to supply is where the marginal cost is bigger or at least equal to the average variable cost. Now in this case the question doesn't mention anything about this, so we're just basically ignoring it. However, bear in mind that that is the condition for the firm to agree to supply. Okay, so given the market price and given that we know the marginal cost for the firm, we would just have to substitute that into here. So marginal cost is 3 on 50 K0 QF. Okay, so this is the quantity for each of the firm. Alright, so this is the supply function for the firm. So if you rearrange this, you can see that QF is equal to P divided by 3 on 50 K0. Okay, so that will just give me 50 K0 on 3 times P. Okay, so this is the quantity supply for each of the firm given the market price. So now in order to find the market supply, knowing that there are 200 firms in the market, okay, and each of the firm is going to be supplying this much. So therefore the market supply, big Q, is going to be equal to 200 times the quantity supplied by each of the firm. Okay, so if you got 200 times 50 K0 on 3 P, and that is just going to give me 10,000 K0 on 3 and P. Okay, so that is the market supply.